This is the plan for the aquarium as it is now. But I propose that a tunnel be added to the large ocean tank. Before this addition, the large ocean tank was known to hold approximately 2,360,000,000 liters of water, and it thus accommodated a certain number of saltwater plants and creatures, which I might point out we've already begun looking into. However, now it's going to hold less water and thus accommodate less ocean life forms. Could I have an exact number to work with? How much water is the tank now going to hold? At this point in the proceedings, I do not see that there is any need to be concerned with how much water the tank will hold. That can be figured out in the future. But what is important is that visitors will be more attracted to an aquarium in which they feel they get a chance to really connect with and be on level with the fish. The vantage point this tunnel will provide will give visitors that feeling that they are really inside the tank with the fish. Ocean life forms. They won't all be fish. Oh, yes, of course. And I see every need to be concerned with how much water the large ocean tank will hold, as budgeting for the aquarium has already begun, and I need to know now how many ocean life forms that tank will be accommodating, and how much that will cost. Well, I think I can explain. The original plan for the large ocean tank was just a big cylinder with a height of 300 meters and a width of 100 meters. So, the volume for the original plan of the large ocean tank was 2,356,194,490 liters. So, the only thing I have to do is subtract the volume of the tunnel from the volume of the tank. This is getting us nowhere. Now just wait and you'll have your numbers soon enough. The plans for the proposed design reveal that the tunnel is just a sine curve and a cosine curve when viewed from above. And the plans further reveal that the tunnel itself is simply a semicircle. There are other details for this design, but those aren't necessary for the problem. Good. Stick to the essentials. You may recall from way back when you took calculus that the integral of area is equal to the volume. Now, because the tunnel is a semicircle, the area is equal to pi r squared over 2. And the radius is equal to the sine of x minus cosine x minus 4. This is because when you put this on a graph, from 0 to 2 pi, you have one period of sine x on top for the upper part of the tunnel, and then one period of cosine x for the bottom part of the tunnel. But because the initial width of the tunnel is 4 meters wide, it becomes cosine x minus 4. So, all we do now is take the integral from 0 to 2 pi of this. So the integral and then so if we are to put this into the calculator, we get thus, the answer is 167.784 meters cubed. Oh yes, that's all very clever, but not very helpful in finding us the numbers we need. Now, if we'll return our attention... He's not done. The number just hasn't been converted to liters yet. But it can't be. Liters measure volume, meters, length. Everyone knows that. Yes, but when SI was invented, it was created so that 1 centimeter cubed equaled 1 milliliter. Therefore, 1 meter cubed equals 1,000 liters. So this is equal to 167,784 liters. Correct. So now if you just subtract the volume of the tunnel, which we just converted, from the total volume of the tank, you get 2,188,411 liters is the volume of the tank with the tunnel. Good. This I can work with. Can we continue now, or do you need to interrupt with more concrete numbers and math lessons? Yes, well, of course we should continue with the further proposed plans, though I did need to interrupt to get that volume of water. Please accept my apologies, everyone. Thank you.